Hi, this is Kevin Trainer. I'd like to welcome you to my tutorial demo on Chapter 9 of the Reggies and Step Java book. Chapter 9 is about inheritance and interfaces. And in this series of tutorials, we're working on inheritance, in particular superclasses and subclasses. And in a previous demo, I gave you an overview of the class model that we're going to be using. So we have moved from having full-blown individual classes for car, motorcycle, boat, snowmobile, etc., to having a superclass of vehicle, okay, and then subclasses that extend vehicle, car, motorcycle, and boat, okay. And the subclasses only have the code in them that is unique to them. And the vehicle class has all the common code. The other thing that we've done is we have introduced this idea that we're going to have a data source class that's going to be used by our annual fee client. And this is going to do a couple of things. It's going to, it's essentially going to insulate the client from having to know the details of individual subclasses. And so the client is only going to know about two things. It's going to know about the vehicle superclass, and it's going to know about the data source class, and it's going to make calls to the method getNextVehicle in the data source object, and it's going to get the vehicle whatever it is. So what we've done so far, what I covered in the overview video, and if you haven't had a chance to watch that, you're going to back up and look at the overview, is I reviewed the vehicle superclass. I reviewed the car subclass. I reviewed the car JUnit test. I even tweaked the car JUnit test a bit to make sure that it fully tested not only all the functionality of car, but the car test also serves as the test for vehicle, because vehicle in this model is an abstract class. And so we can't create direct instances of it, and as a result, we can't really have a JUnit test for it because we can't create instances of the class. I want to point out that if our diagrammer were really behaving, the diagram that we would see here, if vehicle is an abstract class, typically the word vehicle would be in italics. And one of the methods is abstract, the determine annual registration fee. And typically in a diagrammer, that would appear in italics as well. I did have them set as abstract in the diagrammer, but when I exported it to PDF, we lost that typographical feature. Okay, so what are we going to do now? Well, having it got everything to work for a car, now I'm going to get everything to work for motorcycle. Then I'm going to turn it over to you in the exercise and have you do all this same work that I'm doing here for boat. Okay? So what's the work we're going to do for motorcycle? the first thing we have to do is the version of the class that we have is the original class that doesn't extend the vehicle class. So we have to get all the common stuff that we have refactored into the vehicle class. We've got to get that all out of the motorcycle class so that it's lean and mean. Okay, we're also going to have to make it extend the vehicle class so that it gets all that common stuff. We're going to have to make some adjustments to the toString and the equals. We shouldn't have to make any adjustments to a determine annual registration fee. And then we're going to go and we're going to make sure that the unit test works. So once we have a working motorcycle class, then we're going to go over to the data source class, and we're going to make sure that it has test data for motorcycles. And you may recall from the last of the videos that we're going to create 5 test cases for each of the subtypes. So we're going to go create 5 motorcycles. And you'll probably also remember that the data source has a JUnit test class of its own. So then we're going to go and adjust that test to make sure that it tests the new state of the data source, the one in which we have both cars and motorcycles. And the very last thing that we're going to do is we're going to go up and we're going to work with the annual fee client. And the really nice thing there is that we should be able to just run that code again, and it should be able to use the motorcycle data exactly as it gets it without having to change a lick of code in the annual fee client. And that's one of the benefits of this kind of class architecture. All right, let's go start to visit these things. I'm going to open up Eclipse. And what I have here is the project that I'm going to turn over to you before you do your next exercise. I call mine Chapter 9 Demo. And when you import it, you're probably going to want to change the name to Chapter 9 Coding Assignment Solutions. Okay? And it's going to have all my work in it. All right? And you're going to add your work. So where are we? So we've got car working, but not motorcycle. So let's look at motorcycle. And the thing that's happening here is it has all the parts from before before we had the vehicle superclass. Oh, well, let's get rid of those extraneous parts. The only unique field in motorcycle is engine displacement in cc's. So let's get rid of all the other instance variables. Okay, now let's go down to constructors and see what we have. Since you don't inherit constructors, you have to make sure you have the ones that you need. So we've got one here that's a no argument constructor. I like to see those go first. So let's put that right up at the top. Okay, that's our no argument constructor. And then the next one is the fully overloaded one. That looks good too. Okay. And then the next one is the not quite fully overloaded one. It doesn't have a VIN, and you can see that we chained to the fully overloaded one. So that one's going to work pretty well okay too. Okay, so we're going to have to do some work on the fully overloaded constructor, but we'll see. Okay. Let's look at the getters and the setters. Okay, we don't need getters and setters for any of the common fields. So let's start up here, find the common fields, and just get rid of them. We do need them for engine displacement in cc's. Okay, so we need a get and a set, but we don't need them for VIN. Okay, now we have a toString, we have a hash code, we have an equals, but they weren't generated with taking advantage of the common code that is in the toString, the hash code, and the equals in the superclass. So let's get rid of those and we'll regenerate ones that are more thoughtful and take advantage of common code in the superclass. And then the last thing we have is a determine annual registration fee. And there's not a lot that we can do here. We could do something. There's one narrow improvement that we could make, and I'm going to make it in just a second. Okay, so I'll be right back to that. All right, so we got rid of the extra stuff. Now we have to say that it extends vehicle. Okay, that's great. All right, so for the most part, things are looking okay. We don't have any complaints. Now, as soon as we extend vehicle, we can say that we're overriding determine annual registration fee. Now, I just want to point out that technically we are not overriding it. We are providing an implementation, okay? It just so happens that there's not a separate annotation for that, okay? There is an abstract version of determine annual registration fee in the vehicle superclass, and we're overriding it here. How does it help us to add the annotation? Well, again, if we accidentally misspelled, let's say we put 3 E's in fee, now it's going to light up and say, hey, you're not overriding anything that I recognize, okay? So that's how it helps you. It keeps you from accidentally misspelling determine annual registration fee. So that's sort of a good annotation to have there. Again, it says it's an override. It is technically a provided implementation. Okay, we've got that fixed. Okay, not too many more changes to be made. In our constructors, okay, let's see, we have a no argument constructor. It's assumed, it's implicit in constructors that if you don't have a call to an explicit call to the constructor in a superclass, or an explicit chain to another constructor in your class, that what is implicit here is, and I don't know how I got around for it, what is implicit here is this super paren. So there's an implicit chaining to the no argument constructor in the superclass, in this case vehicle. So you can either type that in or not. It's there implicitly if you don't. Okay, so that one is fine now. Okay, now this one that's overloaded, except it doesn't provide a VIN, it uses a null. This changed to the fully overloaded one in this class by using the this keyword. That's okay, I think that's good. Now, should we go ahead and call the setters in our constructor, our fully overloaded constructor here? Well, if you really want to go to best practices, we have a constructor in the superclass that sets the make, the model, the year, the color, and the vehicle ID number. Okay. How about we just chain to that? Okay. And then call the setter for engine displacement in CCs. Okay. So here's what I'm going to do. I'm going to not call most of the setters. Instead, I'm going to chain to super. That's the constructor in the super class. And I'm going to pass expected make, expected model, expected year, expected color, expected vehicle ID number. Okay, so I have one up there that has just that's the fully overloaded constructor up there. Okay, so I'm gonna chain to the fully overloaded constructor in the superclass, which can set everything but the unique field, and then I'm just gonna call the setter on engine displacement. Okay, now could I have left it the way it was when I inherited it? Yeah, this is not a best practice. Okay, here we're only setting things in one spot. So the things from the superclass we're setting in the superclass. That's a best practice. Okay, that looks good. What else do we have to change? Well, we have getters and setters and fine. Then we've got the worker method down here. Okay, now we need a toString. So let's just put this other methods. I like that. And let's say we want to generate a toString. So let's say source, generate a toString. And what are we interested in? Well, we are interested in from the fields engine displacement in CCs, and I think we can do this. I think we can just say now this is how I think we automatically get what we want here. We go down to inherited methods. So we are inheriting the common version of the toString. I think if we come down here and we say, yeah, we don't want to do any of these things, but we do want to call the toString, and we do want to include it. Now let's see what we get here. Did we get what we wanted? I think we probably did. So first of all, let's cut this and put it up here where we want it. Sorry. For some reason it doesn't want to listen to me today. Okay. So engine displacement, and then and then we have a toString and super toString. Okay, that's not a bad way to do it. It's not perfect, but let's see what that looks like. I think that's maybe a more reliable way to get it than I showed you with car. Okay. All right, so that's that. And now let's generate the hash code in equals. Okay, so source, generate hash code in equals. Okay. And I just want to point out that it knows this is a subclass. So all we have to include is the unique field, provided that we want to consider it when we're comparing these. And I don't know why we wouldn't. Let's say OK. So if you look at hash code and equals, they both access the here in hash code we have a call to the hash code in the superclass, and then here in the equals, we have a call to the equals in the superclass. So these things are both they are both leveraging the common code in one case the hash code, in the other case the equals in the superclass. So now I think we've made all the changes that we need to make. So let's get rid of some of these blank lines, and let's try to reformat this a little bit, make it a little prettier. Okay. Looks good to me. Looks very good. So we're going to save this. All right, so now it's time to test. So we have motorcycle. We're going to test that with motorcycle test. Okay. Do we need to change the test much? I'm going to say not much at all. Maybe not at all. Okay, so we test the no argument constructor. That's good. We test the fully overloaded constructor. That's good. We still want to do that. We test the no VIN overloaded constructor. That looks good too. We test the toString. This is going to fail because what our toString is going to look like, it should represent the same data, but it should be slightly formatted differently. So we're going to fail there, but we'll come back and fix this. Test all fields equal. That should work. Equal except for VIN. That test should work. Equal except for make. That should work. Except for model. That should work. Except for year. That should work. Except for color. That should work. Except for engine displacement. That should definitely work. And then we have a bunch of tests for test annual registration fee. We have one for 500 cc's, another for 750 cc's, another for 1199 cc's, one for 1200 cc's. Okay, so I'm thinking the tests are going to be good. The only thing I'm expecting to fail is the toString, and not because it doesn't have all the right information in it, because we've changed the configuration of just the formatting of it a bit. So that's still saved. We didn't make any changes. Let's click it, and let's see. I'm only seeing one failure. They're all green except for test toString. Okay. And let's go down and go to that. So when we compare the expected to the actual, we're not getting what we expected. Well, we changed the formatting of it. So we're expecting that to fail. So let's do the same cheater trick that we've done all along for the toString tests. Let's take all the code out of it. Okay, let's compare it to the empty string. Let's run that test again. We're going to expect to fail. But now, if we go down and we double click on this first line, well, now we can look at what the actual is. So engine displacement 700, and then toString for vehicle Indian, respect 1965, red, vehicle ID number. Oh, that looks great. So I'm just going to right click, it's already selected. I'm going to copy it, clear this dialog, and I'm just going to say in the test for toString, I want to compare to that lovely formatted string. All right, and now I'm going to save it and test it, and it tests just fine. So again, we really tested that one by inspection. Okay, we looked, we inspected it, that's right, and then we put the generated string in there. Now that's going to automatically check for the proper string every time. The only time we're going to have an issue are really cases like that we're in right now, where we're intentionally changing around the format of the toString, and then we're going to have to go back and visually inspect it and make sure we like the new one before we copy that format into our expected test case results. Okay, so we've made the changes to motorcycle. We've made the changes to motorcycle test. Okay, the next thing that we need to do is we need to go and change the data source class. Okay, let's go take a look at that. So here's the array-based vehicle test data source. Okay, and let's see. It's currently creating 5 vehicles and only cars. So let's do this. Let's say we're going to have 10 vehicles overall. Okay, and in addition to cars, we're going to have motorcycles. Okay, and let's just take one of these guys up here to use as a kind of a starter. Okay, so the first motorcycle is going to be index 5. Okay, and then we got let's say that it is a BMW. I don't know their bikes, but Sportster 2015. Say it's black. We have to say how long it is. I know how many cc's. So let's say it's 500 cc's. So it's Sportster. It's let's call it a pipsqueak. Okay, BMW pipsqueak. Say it's a 300. Okay. And let's say the vehicle ID starts with M, and it's not a car, it's a motorcycle. Okay, so that's one. All right, good. So let's just clone that 4 times. Because that's the way you do these things when you have these kinds of tools. 1. Whoop. Let's undo. Yeah, let's get all the characters in our clone, including the first one. Okay, so we want 1, 2, 3, 4. Okay, so they're not all going to be number index 5. It's going to be 5, and then 6, and then 7, and then 8. Not 58, but 8, and then 9. Okay. And let's just say they're all going to be BMWs. So we had, I think, a 300. Now we're going to have a 750. Let's say that it's red. And so it's called Fun Bike. Now the Germans like to put words together. And then another one is going to be BMW. Let's call this next one Fast Bike. Fast Bike. It can be black. Let's make it $11.99. And then the next to the last one, oh, it's not Fast Booge. It's Fast Bike. What? Fast Bike. And then the next one is going to be Big Bike. And that's, that one's going to be $12.50. And then the last one, let's call it Uber Bike. Uber Bike. And that one, that can be black too. And let's say that it's 1600. Okay, and these shouldn't all have the same serial numbers, although we're not doing anything to make sure that they're not the same, but I'm going to make this realistic. All right. Okay. So the first one's going to be 11111. Second one is going to be 22222. Third one is going to be 33333. Fourth one 44444. Fifth one 55555. And then let's say that the years are 2011, 2012, 2013, 2014, and then 2015. All right, that looks pretty good. All right, that should be all that we have to do. We have to make sure that the number of vehicles is the right size to just fit the data in. When we allocate the array, okay, we use the number of vehicles, so it's going to be just the right size. And then we're putting them in just the right array locations. Should take care of it. All right. So let's go down and look at the test for the data source. Okay. Now, if you remember, the test for the data source is expecting 5 cars and then nothing left. Okay. So if we run this test, it should fail, because when we do the 6 get, it should actually bring back the first of the motorcycles. So when we assert null, it's going to be false. So let's run this. Expected null, but was motorcycle. Exactly what we expected. Okay, so let's just take this code we were using to look for the cars and say we're going to expect 5 test vehicles that are motorcycles. Okay. And say that they are instance of motorcycle. Okay. And then we're going to expect the data to be exhausted. Okay. 5 cars, 5 motorcycles, data exhausted. Let's look. Does that work? It does. So there's only one further thing for us to do, is to go up to the annual fee client. And my claim is that once we've adjusted the data source, once we've done all this stuff we've done already, we should be able to just run the client with no code changes whatsoever. Let's look. This is the annual fee client. Let's run it. And let's see what we have. We've got 1, 2, 3, 4, 5 cars, and we've got 1, 2, 3, 4, 5 motorcycles. And I took care to have an example of each of the configurations for the motorcycles so that we could go from a $50 fee to a $75 fee to a $150 fee to a $250 fee. So we have them all. So I promised you we were going to be able to run the client code without having to change it one whit And I just want to show you that that's what we've done. Okay, so I'm going to save this. I'm going to post it to our schedule for you to download as the starting point for your work on the exercises. And you're going to do just what I did in the video right here, except I did it for motorcycle. You're going to do it for boat. It's going to keep you busy. I'm going to say bye until next time. Bye-bye.